In this online video, we're going to discuss how to perform DEA, Data Envelopment Analysis, which is a common tool to assess different service units in terms of efficiency. So for example, talking about restaurants, fast food restaurants, if a fast food restaurant have 10 different branches and the manager want to know which branch is doing good job, which one is not, in terms of efficiency, you can use DEA. So let's look at an example. This is a burger, a fast food restaurant, Burger Palace, fast food restaurant. So the table shows this particular restaurant has 6 different service units. And a second column shows the meals sold. So basically the output from these 6 different service units. So you can see the output are exactly the same for all 6. And we also have the labor hour and the material dollars. So these 2 columns are the input to these service units. So basically for each of these 6 service units, we use labor hour and the material dollar. We buy material, we hire people to produce meals. So output are exactly the same, but inputs are very different. They're very different. For example, for service unit 1, I use 2 labor hours and 200 material dollars to produce 100 meals. For the second service unit, they use 4 labor hours and $150 to produce 100 meals as well. Now, look at all these data. What can we say? Which service unit is doing good job, which one is not? So because the output are exactly the same, and we really look at the input. So whichever service unit use less input to produce the same output, we say this service unit is more efficient. But here, what makes things more difficult is because the labor hours and the material dollar both are the input. So we have 2 kinds of input that makes that assessment very difficult. If we only had a 1 input, it's much easier. So for example, if you look at service unit 1 or 2, so which one is more efficient? So if you compare 1 or 2, service unit 1 is 2 hours for $200. But for service unit 2, is 4 hours, so more labor hours, but less materials. So what can we say? Which one is more efficient? Okay, it's hard to compare. Okay, it's hard to compare. The only thing we can conclude is if you compare service unit 2 with service unit 3, output are exactly the same, labor hour exactly the same, and the material dollars 2 is used more material dollar than 3. That means if you compare 2 and 3, we can say 2 is not as good as 3. So I would say 3 is more efficient. 2 is not as efficient as 3. Okay, so this is the conclusion we can make. Similarly, we can make another conclusion. We can compare 3 and 4. So if you compare 3 and 4, output exactly the same, input, material dollars exactly the same, but labor hours, you can see 3 use less labor hours than 4. So we can say 3 is better than 4. Yeah, because 3 use less input to generate the same output. So this is only 2 conclusions we can make. So 3 is better than 2, 3 is also better than 4. What about comparison between 1 and 6? We cannot compare because in terms of labor hours, 1 is better. 1 use less labor hours. But in terms of material dollars, 6 is better. 6 use less material dollars. So how do we formally compare? Do benchmarking, identify the efficient service units when you have multiple of them. So we have formal procedure. It's called DEA. So data envelopment analysis, we say DEA. It's a measure of organization's productivity. It's similar to the measure of system efficiency. So use of simple ratio may not work because a lot of times we have multiple kinds of input or multiple kinds of output. If you only had 1 input or 1 output, you might consider using simple ratios, but if you have multiple kinds of input and multiple kinds of output, it's just not a feasible solution. So broad-based measures such as profitability are not sufficient to measure efficiency. So corporate management often use DEA to compare a group of service units, for example, fast food restaurants, Burger King, right? You can use this process procedure to assess different units to see which one is doing a good job. You can use the process to measure the performance of different managers. So we use DEA to identify relatively inefficient units and measure the magnitude of inefficiency and discover ways to reduce those inefficiencies. Okay. So this is a basic concept about DEA. Next, we are going to look at a particular example and see how we can perform the DEA procedure. So this is example, same example. So fast food restaurant, 6 different service units. Output, the meals sold, and input, I have 2 kinds of input. I have labor hours, I have material dollars. So this is just given information. So how do we do it? We follow procedure. First of all, I'm going to add 3 rows above. So add 3 rows above. I need to define some coefficient. The idea is when you have multiple kinds of input or multiple kinds of output, we cannot do it. So we have to formally combine multiple input into one input. We combine multiple output into one output. How do you combine them? We need a weight. Okay, we need a weight to combine these multiple kinds of input or output into single output input. So we need a coefficient. So here, if you look at output, I only have one type of output for this particular example. So I need a 1 coefficient for the output. We say it's called U1. Okay, U1, that's a name for the coefficient. If you have 2, let's say if in another example, let's say you have 2 kinds of output, then you need a U1 and a U2. If you have 3 type of output, then you need U1, U2, and U3. Now here we only have 1. Then we also need to know the value for this particular U1. U1 is a name of efficient. We need to have a value. So this value needs to be determined. So I'm going to highlight this value in green. So this is a number we need to determine later. Okay? How do we combine different input or output? So this is called output. So output, I have 1 output. That's why it's only U1. If you look at input, I have 2 kinds of input. So I have 2 kinds of input. So I need a coefficient for input as well. So we have V1 and V2 because I have 2 input. If you have 3, then you need V1, V2, and V3. If you have 10, then you need V1 all the way to V10. So U is a coefficient for output. V is a coefficient for input. So it depends on how many input and output you have, then you need a different number of U1, U2, U3, or different number V1, V2, V3. Okay. Then I have a value for, I need underneath V1, V2, I need to figure out the value for V1 and V2. I highlight in green. So these 3 numbers are the numbers I need to determine. Okay. What is the coefficient value for U1? What is the coefficient value for V1 and V2 so that we can combine different input and output into a single one. So once you set up the table like this, we can fill the rest of the table. Okay. First of all, let's look at what is the aggregate output. As I said, when you have multiple input output, we cannot do comparison, we cannot do benchmarking. So we have to aggregate all the output into a single output, and then we have to aggregate all the input into a single input. So here, let's look at the first one, the first service unit. Okay, for the first service unit, so before we do that, I'm going to start some initial value. For simplicity, I do all ones. So this is not important. You can do different number. You can do 111 or do 000 or do half. It's up to you. You can leave it blank. Okay, it's all fine. So I'll start with 111. Eventually, I will let Excel change it. So this is the initial value for coefficient. U1, V1, V2, V2. So based on this, I need to aggregate. Okay, for service unit 1, because I only have one output. So this is easy. The way you do it is basically coefficient times the corresponding output. Here, I'm going to log B3. The reason is for all other service units, we're going to use the same coefficient value. So that's why I log B3 times the corresponding output for service unit 1, which is 100, B5. So that is the aggregate output for service unit 1. Okay, so different efficient will have different values. So we make sure I log B3. Then I can do this for second one. For second service unit, what is the aggregate output? The aggregate output should be efficient coefficient value times the corresponding output, which is 100. Okay, so this number times this number. Okay, what about service unit 3? Will be coefficient value times the corresponding output, this number. So you can see the formula will be B3 times B7. Next one will be B3 times B8. Next one, B3 times B9. The last one, B3 times B10. So all these combinations, when you calculate the aggregate output, so all these service units will be using the same coefficient value, which is B3. That's why I locked it. Okay. So to make things easy, since I already locked it, I can just drag it down. So for example, if you look at service unit 5, you can see, double click it, you can see the formula. The formula is coefficient value times corresponding output. Okay, so that's how we aggregate. Aggregate output into single is called aggregate output. So now let's move to input, aggregate input. So how do we aggregate input? We take our weighted average, okay, by using the coefficient value. For example, if you look at service unit 1, how do we aggregate? I have two kinds of input. How do we aggregate? Make it one input. So we're going to use coefficient values. So the way to aggregate will be the coefficient value 1 times the corresponding input, which is 2, plus the coefficient value 1 times the corresponding input, which is 200. So that's how we aggregate. That's how we say take weighted average. Okay. So 1 coefficient value, these two numbers, you can view these two numbers as a weight. We take the weighted average. So 1 times 2 plus 1 times 200. So if you recall the structure like this, we can use a function called sum product. The first two coefficient value, I'm going to lock it by pressing F4. Because for all other service units, I'm going to use the same coefficient values. That's why I lock it, so I can drag it down. Then I choose C5 and D5. That's input value for service unit 1. So that, if you do this, you're going to get the aggregate input. In other words, this is a weighted average of input. The idea is we don't want two input. We want one input. So we have to combine these two inputs by taking weighted average. So the coefficient value is the weight. Currently it's 101. Eventually we're going to change it. We'll let Excel change it. So once we have the aggregate input for service unit 1, I can do this for 2, 3, 4, 5, 6 similarly. Here, because I already locked C3, D3, I can simply drag it down. Okay. So for example, if you look at the last one, service unit 10, the way I did it is I do a sum product and C3, D3, and then C10, D10, because I locked it. So that gave us a weighted average. Okay. Now I have the weighted average for the output. I have weighted average for the input. So basically, I only have one output. I only have one input. That makes comparison doable, easy. So let's say if this is the weight, okay, of course this is the arbitrary weight. We're going to change it later. If say this is in fact the optimal weight, you can see the output is exactly the same, the input. The last service unit has the smallest input. So you can see if this is the coefficient value, then service unit 6 is the best one. Service unit 1 is the worst service unit because this one has the highest input. So the question is, these three numbers are arbitrary, the initial starting value. We need to change it. We need to figure out what is the optimal one. Okay. The last one we need to do is that you look at titles, output minus input. So output, which is E5 minus input, which is F5. So you do this for every single unit. Okay, every single unit. That's how we fill the table. Okay. So fill the table, we need to do add 3 rows above the given information that creates coefficient depending on how many output we have, how many input we have. Okay, we have U's and V's. The number U's depends on the number of output. The number of V's depends on the number of input. Then we create a formula to calculate what is the aggregate output. So based on U, okay, the combination, weighted average. Then we also need to calculate the weighted aggregate input using the value for V1 and V2. These are the coefficient values or the weights. Then we do the difference, output minus input. That's how we fill the table. So once we have the table ready, we can go and assess the efficiency of different service units. We're going to use solver again. So click data, click solver. So how to do it? So first of all, we do that decision variables. So by changing variable cells. So changing variable cells will be the weights, all the weights. You choose all the coefficient values. Okay, all the weights. Here I have 3. And what about constraint? The constraint, I have one common constraint. The common constraint says the output minus input should always be less than or equal to 0. That means output cannot exceed input. Okay, you don't have to understand the why. Just make sure you always have such a constraint. Okay, output minus input is always less than or equal to 0. Output cannot exceed input. Okay. So during the process, you may waste some materials, so that's why you cannot go above the input. So input output the difference, output minus input always less than or equal to 0. So that's the constraint. Okay, regardless which service unit you want to assess, you always have this constraint. So decision variables, always the coefficient values. Constraint, you always have one constraint, which is common to all the sub-problems. Whichever service unit you want to assess, you have this common constraint, which is output minus input, always less than or equal to 0. Then we need to fill the objectives. Okay, we need to fill the objectives. So the objective depends on which service unit you want to assess. Okay, when we assess these 6 different service units, we have to do one by one. We have to repeat the process again and again. So now let's say let's assess the first service unit. So if you want to assess the first service unit, the objective will be the aggregate output of the first service unit, the service unit 1, which is E5. If you want to assess service unit 1, you're going to use the aggregate output for service unit 1 as objective, and you want to maximize it. Okay. So next, if you want to assess service unit 2, then you'll have to choose the aggregate output for service unit 2 as objective, and you want to maximize as well. So this is, be careful. So objective depends on which service unit you want to assess. So whichever service unit you want to assess, you want to choose the aggregate outcome for that service unit as that objective. You want to maximize it. So in terms of constraint, we have one common constraint that applies to all the service units. So regardless of which service unit you want to assess, you have this constraint. We also have another constraint. The second constraint depends on which service unit you want to assess. So here, because I want to assess service unit 1. So I want to have another constraint. This constraint says the aggregate input for that service unit has to be equal to 1. Okay, have to be equal to 1. This is the second constraint. Normalize. Okay, normalize. So let me repeat. Okay. First of all, in terms of decision variables, it's always the coefficient values. Choose all the coefficient values as decision variables. In terms of constraint, I have one common constraint that says all the difference between output and input for all the service unit should always be less than or equal to 0. So in terms of objective, it depends. So the objective depends on which service unit you want to assess. So here, because I want to assess service unit 1, that's why I set the aggregate output for service unit 1, which is E5 as objective. I want to maximize it. And for the constraint, in addition to the common constraint, I also have an additional constraint that is specific to the service unit you want to assess. Here, because I want to assess the efficiency for service unit 1, I choose the aggregate input for service unit 1, which is F5. I make sure this one is equal to 1. You normalize, okay? Normalize the aggregate input for that particular service unit to 1. So I have two constraints. Then I choose simplex LP. I solve it. Click OK. Now let's look at it. So here, remember, here we're trying to assess the efficiency for service unit 1. So which number do we look at? We look at this number, aggregate output. Okay. So once you solve it, I look at the aggregate output for a specific service unit, which is service unit 1. Okay. Don't look at these numbers. These numbers are not relevant. Okay. Only look at this number because I'm trying to assess the service unit 1. I'm trying to assess service unit 1. I look at the aggregate output for service unit 1, which is 1. 1 means 100. 100 means service unit 1 is efficient. Okay, is efficient. So we don't have to do anything about it. So service unit 1 is doing a good job. We don't have to worry about it because it's 1. 1 means 100%. 100% good, efficient. So same example. How do we assess service unit 2? So if I want to assess service unit 2, some people say it's 1 as well. Okay, that's not relevant. Okay, so we have to repeat the process. Okay, we have to repeat the process. If I want to assess the efficiency for service unit 2, I have to repeat the process. So in terms of filling the table, it's exactly the same. So I'm going to use the same table. But in terms of using solver, it will be a little bit different. Okay, we have to change it. So now let's assess the efficiency for service unit 2. Table the same, solver will be different. So if you look at solver, decision variables will be the same. Will be the same 3 numbers. Constraint, one constraint will be the same, this one. So all the difference will be less than or equal to 0. This is the same common constraint, but the objective will be different. When you assess, if you're trying to assess service unit 2, the objective will be different. It's no longer E5, it will be E6. We'll have to, if you want to assess service unit 2, you have to choose the aggregate output for service unit 2 as objective. You want to maximize it. So this will be different. And also the constraint, one of the constraint will be different. It was F5 equal to 1. We have to change it. Okay, we have to change it. Because we want to assess service unit 2, I'm going to make the aggregate input for service unit 2 and make it a 1. So I've choose, instead of F5, I choose F6 because F6 is aggregate input for service unit 2. So make it a 1. Click OK. Okay. So make sure you change the 2 things. Objective will be different, and constraint, one constraint will be different because now we're assessing service unit 2. So click solve. So look at this number. Okay. So now we're assessing service unit 2. We'll look at the aggregate output for this number. Aggregate output for service unit 2, which is 0.857, which means what? Which is below 1. It's not 100%. It's 85.7%, which means service unit 2 is not doing a good job. It's not efficient. It's not doing the best it can. There's room for improvement in terms of efficiency. Okay, so that's how we do service unit 2. Similarly, we can also do other service units. For example, if you want to do what if we want to do service unit 4? How do we do it? So table will be the same. Okay, table will be the same. We don't have to change anything. We just need to change the solver. Let's say I want to assess service unit 4. So objective, change objective. Now the objective will be the aggregate output for service unit 4. And maximize it. Decision variable same. Constraint. This is a common constraint, but this constraint is specific to your service unit you want to assess. So right now it's F6 equal to 1. We have to change it because we want to assess service unit 4. We make the aggregate input for service unit 4 equal to 1. Click OK and solve it. Look at this number. It's 0.8888. It's less than 1. If it's less than 1, we say this service unit is not 100% efficient. It's 88.88% efficient. So that means there's still room for improvement. So before I finish, I want to do one more service unit, which is service unit 5. The table will be the same. I change solver. Objective is no longer E8 because I want to assess service unit 5. I do E9. So E9, the aggregate output for service unit 5 will become the new objective. We want to maximize it. Decision variable same. Constraint, this is a common constraint, but we need to change another constraint which is specific to the service unit you want to assess. So it's no longer F8. We change to F9. Okay, for service unit 5. Make it 1. Solve. You can see it's 0.909. What can we say about it? That means service unit 5 is not 100% efficient. It's only 90.9% efficient. There's room for improvement. Okay, so you can do this for every single service unit following the same procedure.